apply Duhamel's principle to provide an integral formula for the solution of this initial value problem. So we are trying to find out the formula for xt, and this will be an integral formula. So this one, by Duhamel principle, this will be actually the convolution of the weight function and the function ft here. So let's do that. We Laplace transform both sides. X double prime, 6x prime, 8 times x, Laplace transform of small f. Because initial conditions x0 equal to 0, x prime 0 equal to 0, if we note big X equal to Laplace transform of small x, this one will give us s squared 6s 8 times big X equal to Laplace transform of ft. So because of this condition, the only term that's non-zero here is s squared times big X for this term, 6s times x for this term. So the other term, because of this condition, they are zero. That's why we have this nice formula. Big X equal to 1 over s squared 6s plus 8 times Laplace transform of small f of t. Now this one, this function 1 over s squared plus 6s plus 8, this is a transfer function. W of s, the transfer function. Now we try to find the inverse transform of that transfer function. That's what will give us the weight function. Omega, so this is small omega t, inverse transform of ws. This one is the weight function, omega t. Now inverse transform of this fraction, you can use partial fraction decomposition. So inverse transform of, we have here 1 over s plus 2 s plus 4. So I see that 2 plus 4 is 6 and 2 times 4 is 8. That's why I can factor it like that. Inverse Laplace transform, here's how I do it. S plus 2 s plus 4. Up there I should have s plus 4 minus s plus 2. So you see that s cancel out. 4 minus 2 is 2. So I have 2 left. I need to divide by 2. Divided by 2. So that 2 divided by 2 will be 1 here. Now I can split that. First I move the 2 outside. 1 over 2. Inverse transform of, so this term minus this term. So the first term, s plus 4 cancel out. You have 1 over s plus 2. Second term, 1 over s plus 4. With that, you don't need to solve for the constant AB in the partial fraction decomposition. Otherwise, you can do that and you get this one. Here's an inverse transform of the first term, e minus 2t. Inverse transform the second term, e minus 4t. That one will give us omega t. Big X equal to w times Laplace transform of small f, which is Laplace transform of the weight function omega t times Laplace transform of small f t. Laplace transform of this function times Laplace transform of another one, Laplace transform of the convolution of omega and f. So this is the properties, products, and convolution. This is big X, so small x t is the inverse transform of the right hand side. I do inverse transform both sides. So small x equal to omega star f, convolution of omega and f. And by definition, this is equal to 0 to t omega tau f t minus tau d tau. So this is the integral formula they talk about in this exercise, the Duhamel principle. And by the way, this convolution is commutative, so you can also let this equal to f star omega t. So we get this formula. Now just write down this one explicitly with our function omega t, which is this one. Omega t is this function. So we need omega tau 0 to t omega tau minus 2 tau minus 4 tau f t minus tau d tau. So this is answers. You can also group e minus 2 tau outside if you want. For example, 1/2 0 t e minus 2 tau inside 1 minus e minus 2 tau f t minus tau d tau. I can also write down the solution as hyperbolic sign. So I can also group it. So another option is from this one. Another way to group it is 0 t 1/2 still there, e minus 3 tau, and inside you have e tau minus e minus tau, and the rest. So you see that here, this term divided by 2 a hyperbolic sign 0 to t e minus 3 tau sink of tau f t minus tau d tau. This is also a good formula. These are the integral formulas for xt. We can choose either one of those formulas.